This nanowire-based plasmonic circuitry simultaneously transports electrons and surface plasmons in a shared information support. First, dropcast a colloidal solution of silver nanowires on a glass cover slip pre-patterned with alignment marks. Then, using a design software, select extremities of nanowires to precisely fabricate the contacting electrodes by electron beam lithography. Next, investigate the property of the contacted silver nanowires under a surface plasmon leakage radiation microscope. Results of the surface plasmon effective index and propagation length can show the evolution of the surface plasmon characteristics as a function of biased voltage applied.
I first had the idea to develop this method when it became clear that crystalline silver nanowire can be used to transport an electrical command and carry an optical signal simultaneously. Demonstrating the excitation of a surface plasmon in a nanowire will be Juana Rocas, an engineer from my laboratory.
Dilute the nanowire solution in ethanol to obtain a nanowire density on the substrate of about 1 nanowire every 10 square microns. Then pipette 50 microliters of the solution and drop cast it on the pre-patterned substrate. Blow dry with nitrogen. Place the substrate decorated with nanowires on a standard calibrated optical microscope. Precisely locate the extremities of a series of isolated high-quality nanowires with respect to the closest alignment marks.